Rust, the end of the speed versus safety compromise. For decades, the software industry was forced to accept a difficult trade-off. You could choose control and speed C, C++, accepting the risk of critical memory crashes. Or you could choose safety and productivity Java, Python, accepting the performance penalty of a garbage collector. Rust was built to break this rule. Since its version 1.0 release, Rust has consistently topped Stack Overflow's most loved language survey. It is not just a trend, it is a fundamental shift in systems programming. Here's why Rust is taking over job 1. Ownership, the secret sauce. The defining feature of Rust is a unique memory management model, ownership and borrowing. Unlike C++, where you manage memory manually, or Java, where a garbage collector manages it for you, Rust manages memory at compile time. The compiler enforces strict rules. Each value has a variable that's its owner. There can only be one owner at a time. When the owner goes out of scope, the value is dropped immediately. The result, you get memory safety without the runtime overhead of a garbage collector. It eliminates entire classes of bugs, such as no pointer exceptions and dangling pointers, before the code even runs. 2. Zero-cost abstractions. Rust follows a strict philosophy. What you don't use, you don't pay for. High-level programming concepts usually come with a performance cost. In Rust, high-level abstractions like iterators or closures are compiled down to the same efficient machine code as if you had written low-level loops by hand. This makes Rust ideal for embedded systems running on tiny microcontrollers, WebAssembly powering high-performance web apps, game engines where every millisecond of frame time counts 3. Fearless concurrency. Multi-threaded programming is notoriously difficult because of data races, bugs that occur when the threads try to access the same data simultaneously. Rust solves this with fearless concurrency. The same ownership rules that manage memory also manage thread safety. If you write code that could cause a data race, the Rust compiler will simply refuse to compile it. This empowers developers to write aggressive, parallel code without the fear of random crashes in production. 4. A modern toolchain, Cargo, coming from C or C++. The Rust tooling feels like a luxury. Rust comes with Cargo, a built-in package manager and build system. Managing dependencies is effortless. Running tests is a single command Cargo test. Generating documentation is built in Cargo Doc. Cargo creates a standardized workflow that makes starting a new project painless. 5. The challenge, the learning curve. Rust is powerful, but it is not easy. The compiler is strict. New developers often struggle with the borrow checker, fighting to get their code to compile. However, this struggle is valuable. The compiler is teaching you to think correctly about memory. Once your Rust code compiles, it usually works exactly as intended. The verdict, the future is Rust. Rust has graduated from a niche experiment to an industry standard. Linux. Rust is now the second official language of the Linux kernel. Microsoft is rewriting core Windows libraries in Rust for security. Amazon OS uses Rust heavily for its serverless infrastructure Firecracker. If you are looking for a language that offers the raw power of metal with the safety of high-level code, Rust is the technology of the decade. Would you like me to explain the concept of ownership in more detail with a simple code example?